Welcome to the Part Information Management session. The session will share and introduce Silicon Expert's contribution into the part selection and qualification process. My name is Nikola Kontic, and I'm joined today by Oliver Hoffmann from Silicon Expert. The session will be divided into three sections. Firstly, looking at the challenges for design engineers in the product design process, an introduction to Silicon Expert's offering, and finally concluding with a demonstration of the integration of Silicon Expert into the domain data management solution offered by Zuken, known as DSCR. Engineers need to design new and innovative, unique products and also look at new technological designs. Engineers face challenges and difficulty in collecting and accessing the correct component information. Often we need to look at multiple systems for information, and sometimes there is a lack of information to make those informed decisions. More recently, engineers must consider more than just the functional aspect of a component, needing to consider the form and the fit. As those engineers' tasks expand, there's an opportunity to improve the cooperation between engineers and procurement, leading to a much smoother adoption of the parts selected into the corporate library. Other aspects are the project timescales and costs are considered constraints, and these must be observed and achieved. Also, looking at the target market for the product sales can impact the selection of the components. The components must be compliant with RoHS, materials used in those components, for example Prop 65. Looking at the impact on costs for changing parts and part selection during the product life cycle. At the planning and concept phase, key decisions are made. It is at this stage that part changes can be done with minimal impact. During the physical design and production, part changes could mean a minor design rework, or worse, a complete design respin. The cost of change when a product is released to the market is significant in both cost, time, and resource. From the point of selecting alternate parts, during the concept and planning, it's easier to find alternate, while later in the design process, when decisions and commitments to the design stage means alternates will need to be carefully considered as they'll impact the design work already done. Considering part selection methodologies, we can consider from 3 points. Firstly, strategic. A strategic approach to selection may consider the product life cycle. We may consider acquiring the components in volume in advance. This could be done for avoiding requalifying a product, since the requalification process could be significant. But the contrary to that, some components may not have the required shelf life. Another strategy may be at a corporate level to only purchase from an approved manufacturer list or approved components lists. From the predictive or proactive point of view, we need to gather information from the manufacturers about the end of life plan, looking at product change notification, end of life, and not recommended for new designs. And finally, from the reactive point, parts that are last time to buy or may already be end of life, we need to take an action to solve any projects that already have those parts used in them, while also flagging the issue to other potential products and projects that are ongoing. Other aspects to the selection methodology needs to consider the supply chain, the product availability, the cost, the lead time, and how this can affect during the product life cycle. The current issues regarding a volatile pricing lead time has certainly impacted businesses today. Let's look at the impact of the part selection during the design process and the decision making. Taking a general overview, small to medium enterprises may use engineers as librarians, part qualifiers, and use and provide bill of materials to EMS companies or directly purchase from distributors, whereas large companies may have a domain data management solution and even a enterprise level management solution. So these large companies may have global corporations that have procurement teams, and the part selection process is submitted for qualification by these procurement teams. They provide the due diligence and find the multi-sourcing, the part alternatives, the best price, and make sure that the stock levels required for the projects in hand. Generally, during the design process, all the engineering roles will use a similar criteria for selection. During the planning phase, engineers need to consult technical specifications, look at the functional aspects to select the part, considering performance and any supplementary circuitry that may be needed. During the circuit design, the part availability, the timescales, the cost, the specification as the circuit involves must be considered. It is at this stage that we need to provide the information for the parts to be registered in the ECAD library for use in the capture and the circuit design and the physical design phases. When we get onto the physical design and manufacturing, needing to consider the fit of the part, the packaging, the size, the height, the weight, etc., how it fits in the enclosure and on the printed circuit board, all need to be considered. Additional design elements such as heat sinks, the assembly and the location on the board all need to be considered. And when we get into the manufacturing, much more it's the combination between the ECAD and the MCAD and how the components fit in the enclosure, spacing, etc. Finally, when the product is released, the impact for part replacement due to obsolescence, cost, availability and lead time need to be considered. For engineers, we look to how the supply chain is performing, any inventory levels, but obviously the costs will play a major impact whether we need to make a part alternative if the costs become exceptional. I'd like now to introduce Oliver Hoffmann from Silicon Expert.
This is Oliver Hoffmann from Silicon Expert, and within the next 10 minutes we are going to look at how Silicon Expert supports data-driven decision-making with a human-driven experience. With that, we mean that our 21 years of history have enabled us to capture, meanwhile, more than 1 billion components, data sheets, and lifecycle data and environmental compliance data with the help of our 400 electronics and software engineers. That totals to more than 8,000 man-years of data and experience of components from more than 15,000 different manufacturers. But it's not just collecting data and data sheets. We are even applying forecasting algorithms and machine learning to give you a really good overview about what is necessary to do data-driven decisions about multiple aspects on electronic components. We consider that throughout the company, several different colleagues are going to enjoy the pleasure of data-driven decision-making. So this is relevant for colleagues in design and product engineering. Operations and manufacturing will have probably slightly similar, but also some complementary interests, whereas supply chain and finance and compliance in general are also making data-driven decisions, but probably on different aspects about the very same component. Therefore, in engineering, we think that parametric data, things that describe the packages, gives insight into manufacturing prerequisites, and of course end of life is pretty meaningful to make data-driven decisions about. So the assumption is that we might want to know parametrical data about a TBS diet that has a single configuration that is bidirectional and comes with 11 volts and 400 watts. Then Silicon Expert shows us what the world market has to offer. So it's a pretty quick screening of the market. And in order for us to know more about an individual component, we can click at the according manufacturer part number, and Silicon Expert allows us to review technical data, for example, about what we could digitize out of the data sheets, everything about the package, manufacturing insights such as moisture sensitivity levels or reflow temperatures, and most important, which we have directly seen when Silicon Expert presents a search result, that is what we call the years to end of life. This is based on an algorithm forecasting with approximately 93% accuracy in how many years the component is going to be obsoleted by the manufacturer. Again, this is a forecast based on an algorithm that Silicon Expert has been continuously improving for more than a decade now. Next group of users making data-driven decisions with Silicon Expert are in operations and manufacturing. Lifecycle forecasting is one of the key interests that we see there, but also proactive alerts and the ability to find alternative components, the cross-references. So the proactive alerts is what you receive through Silicon Expert with this bell symbol right here at the top. I have asked my Silicon Expert license to let me know if something is happening with the life cycle of my components that I'm having in my bill of materials. This might result in a notification that looks like the certain part number from a specific manufacturer has an obsolescence notice, and it's looking like this. It has been issued on May 31st. It's now on Silicon Expert, and it lets us know that it's a product end of life notification, enabling us to find an alternative. And this alternative can be found, for example, by entering the desired part number in Expert and just looking at the amount of crosses that Silicon Expert can help you to review in order to find the best possible fit of components. Therefore, we just click on the number in the according column that shows 341 crosses. These 341 crosses are alternative components. Overall, Silicon Expert has more than 5 billion alternative components relationships in its database. They are even graded by different types of A and B and C, just so that you have a good understanding about what is a technically equivalent component and which is just a similar component, basically. There's another role within supply chain and procurement where it's maybe not too intensively being discussed what is my technical attribute looking like, but how available is the component? Can I design this component in? And this data, this information is not just relevant for procurement and supply chain, because engineering can look at this data ahead of time. You don't have to wait until procurement and supply chain verifies these. You can look at these easily by yourselves. So with availability and inventory and lead time on our minds, there is, for a certain component, a bit of supply chain background which we could review. We would see how many and which distributors have how many components on stock, but we also see a history about how the minimum and average price for a single component has been increasing and decreasing on a bi-weekly basis throughout the last year or so. We also see the evolution of lead times with minimum to maximum lead time over the last approximately 9 to 10 months. So this helps a lot to understand if this component has had bottlenecks, allocations, or strong price trends throughout the last couple of months, so that you know what you are dealing with. you can decide for a component that you know as much market behavior about as if you had this designed in for the last couple of months already. There's another element to Silicon Expert which does not just show you what is the trend of the past. We can even apply machine learning algorithms to predict for the next 3 months, which would be our supply chain module that interpolates the next 3 months for price, the next 3 months for inventory, and also the next 3 months for lead time behavior. Okay, so with finance, the interest of ours would be which components are risky, which kinds of alerts can I subscribe to, and if a problem occurs, how can alternatives help me to reduce line downtime. Finding alternatives quickly, we have already seen. Measuring how much money can be saved by lengthening the duration in between multiple redesigns is something that can be measured within the internal finance departments, whereas identifying those components within a BOM that are either generally high cost or high lead time is also prepared by Silicon Expert with a certain report. Such reports are available for the uploaded BOMs, whereas there are approximately 15 different reports within Silicon Expert that are available for each bill of material, whereas the one that I am referring to make decisions about price and lead time or to get a good overview is the so-called price and lead time report, indicating the average and minimum price for each component, also listing the minimum and the maximum lead time, where you can quickly identify those that might be risky, depending on how much flexibility you have in between today and start of production. Quality and compliance. It's those colleagues among us who are either enjoying or at least challenged by how REACH and RoHS and Tosca and SCIP and California Proposition 65 are asking us for more due diligence. We also take care of when we order a component, it would be like if we really receive the one that we have ordered and not a fake component. We also deal with conflict minerals, and all of these are of course taken care of in Silicon Expert as well. On our part details pages, there are plenty of insights about compliance. Here you're finding a couple of directives which we have backed up with written data from the manufacturers, and partially also we succeeded in digitally capturing the material declaration sheet and deciding based on the included substances which of these directives is affected or unaffected. The conflict minerals data is at the bottom of this page, telling you if a certain manufacturer or component is undeterminable, affected or unaffected. And quality-wise, when it goes to certain agency approvals as ESD or as UL certificates, this can be found within Silicon Expert as well. Okay, at least all of this data which Silicon Expert has collected for individual components needs to be used by the right colleague at the right time. So we are talking about business processes. And when it comes to authoring, designing new electronic designs, circuit boards, schematics, the right tool in which all of this data gathering should happen is the electronics design automation. And Silicon Expert is happy and proud to be partnering with Zuken and to enjoying the next presentation in which we see how Silicon Expert data is being streamed into the Zuken electronics design automation suites and to be used by the users for intelligent data-driven decision making. Thank you very much, and yeah, looking forward to the next presentation. This was Oliver Hoffmann from Silicon Expert. Bye-bye.
Thank you, Oliver. That's very helpful. The vast amount of information available in Silicon Expert will greatly help my component part selection. So before I move into the demonstration, I've broken down the demonstration into two elements. Firstly, the part selection and pulling in the information from Silicon Expert into the design authoring tools in the data management, and also then how to handle part obsolescence. So here we have the domain data management solution from Zuken, and I have the information of registering a part in the component master element of the domain data management solution. So the library management aspect here, we've registered a part prefixed MP, and it uses a manufacturer's part number ADA 4000, but I don't have any further detailed information on it, and I'm going to pull this from the Silicon Expert environment. But firstly, just to show you the information for the part, if I edit the part, we can see that there is no information, just a skeleton placeholder for this part with a footprint and a schematic symbol. Now, using the Silicon Expert to investigate, research a part, we can see the information available for this part, the data sheet, the life cycle, etc. And if I look into the detail, I can perform my risk analysis as an engineer, looking at the alternatives, the crosses, at the grading level of the crosses, be that A, B, C, whether it's an upgrade or a downgrade. And we see lots of information in this view. Firstly, we can look at the technical information from an engineer's point of view that I want, the temperatures, the performance, the operating and manufacturing information. Also, we can see simulation models here, and we can access them, or even the ECAD models we can download, get access to a schematic symbol, footprint, 3D model. We can look at the compliance, as I mentioned previously, looking at how the part works, the materials used, looking at if the component has a healthy supply chain. In this case, it looks good. Pricing, we can see the history of the pricing, as Oliver mentioned, looking at how more recently in the last 6 months the pricing has fluctuated a little for this part, and the lead time has increased more recently for this. At the risk analysis overview, we can look at the life cycle, the sourcing, compliance and inventory, and this gives me an overview on how good the part will be for my particular project. We can see the history of the data sheet and any product change notices. So once I'm happy, I can then start considering pulling that information in from the Silicon Expert environment into my component master within the domain data management solution from Zuken. And we can see all the information available within Silicon Expert and choose which information we want to pull into the DSCR component master. We can see here the physical information, and again choose which of that information we want to import into the component master. And now we can see that that information has been imported in. And this can be done on a automatic basis, on a regular, for example, and overnight we can pull the information from the Silicon Expert. Now if we look at the part model, we can see the information has been imported into that part, and we now go through the process of taking that component master and passing that to the different component databases available in the CR-8000 environment. Because, as I said, we've got it in the component master in the data management solution, library management aspect, but we need to then push out and synchronize with the different libraries for each division in a company. And as we can see here, the part has none of that information yet, and we'll synchronize this component database from the component master. So it's very simple to perform that component synchronization library. Again, different divisions can have different parts available, so I may have to do this for several different divisions, but we synchronize the component master to each of those component libraries for each division. And again, this is an automated task performed, but it then distributes the information from Silicon Expert to each of the divisions and each of the component libraries available. So if we now look at the part information, we can see that the information is now into those released libraries. So now taking the example of a part being reported by Silicon Expert that is obsolete, we can see again in the library management aspect of DSCR that we have some parts that have gone obsolete, and we need to then perform and look at where these parts are used. So just taking one example of this part, we look at the part information, and we can already see from Silicon Expert we imported in a part alternate available for this previous part number. So we'll take that information. It's a bidirectional status, so it's an equivalent, identical equivalent match to be swapped out with no design rework. We can then look at the where used. From the original part, we can see which projects have used it and consider what work needs to be done. Now again, this is performed because in the data management solution, each project has a bill of materials associated. So let's look at the bill of materials for project number 20, and we'll see that this 74AC14 is used. And we have, looking and sorting the list of the bill of materials by the life cycle, we can see that there are two different components that are obsolete, but we'll just look at the 74 component and look to update the circuit data. But firstly, updating the bill of materials within the main data management solution, we can see that the alternate part is registered in the system, so we can then commit that into the updated bill of materials. So that is updated IC24. If we look at that, we can see that the new company part number is the suffix D1. We can now also update the IC25 as well. We could have done that as one step. I'm just performing it just individually. As you can see, one might do for different parts if I wanted to swap it for a different part. So now looking at the bill of materials, we can see that both of the instances, IC24 and 25, have the updated component part number. But again, this is just updated the bill of materials part numbers in the domain data management solution. We may now want to reflect that back into the circuit data. So let's firstly compare it to the circuit data. And within this, we can see that the circuit data contains the 74AC14, but the bill of materials has the D suffix. So we need to perform the task. And I'll just do it on the one so we can see how it reflects it into the circuit data. But we'll perform without running the tool and manually doing it. This will be an automated task which will update the circuit data to reflect the new part in the circuit. Now we'll look at the circuit data and compare that we have IC24 using the new part number and IC25 will still be using the old part number. And here we can see the circuit where it's automatically been updated in step with the bill of materials now, and we can make the appropriate change to the circuit data from the bill of materials for the IC25. So we've shown you, and the takeaways are that the information available through Silicon Expert will greatly help you in the part research, in the part selection process, reducing engineers' overall design time. It's a single source of information for the engineers with a vast amount of information consolidated into a common repository. The information available will aid the procurement team in the qualification process. Silicon Expert provides this cross-grading to make part replacements much easier. Looking at obsolescence, it's much more efficient and a quick action now to replace those parts. And with continual online access, we get the notifications or we get the overnight updates from Silicon Expert. We're up to date with the status of parts available, and we're alerted to the potential risks in the product life cycle should there be any. Thank you for listening to the session today, and I welcome any questions.